Welcome, scientists. Today's topic is engineering design, and our essential question is, how do engineers solve problems? So, before you begin, make sure you've got those written down in your Cornell notes, and then go ahead and press play. So, what do engineers do? Please take notes on this. Engineers make things. They use mechanical things, they fix stuff, they keep things working, and they upgrade stuff, and then finally they work with technology. So, if we were to say engineers are one thing, maybe one or two words to fill in this blank, what would we put there? Above all, we would say engineers are problem solvers. Please do write that down. So, a little bit of review. What is homeostasis? We've been talking about it for a while because it's really, really important. Think about it. What is homeostasis? Homeostasis, our technical definition, is the maintenance of a constant internal environment when outside conditions change. Essentially, that just means you need your insides to stay stable. You want to keep things on an even keel. Our bodies don't like to have lots of changing variables going on. This is our wrap video for so many systems. It's talking about all of the body systems, and it's a little bit amazing and a little bit terrible, so I hope you enjoy. If at any point you need to skip ahead, go ahead. I will understand. I would also recommend turning the volume down a little bit.
So many systems.
Endocrine, excretory,
Our body system.
nervous, reproductive, and digestive. Do you get me?
So many systems.
Respiratory, circulatory,
What are these systems for?
muscular, skeletal, immune. What it do?
Breaking down food so we can be healthy, bringing in nutrients and energy to help me start digesting when you chew it in your mouth, down esophagus to the stomach, no doubt. Small intestine, large intestine, traveling through the tubes. My food is on a slip inside and then it turns to poop.
Yeah, yeah. Drip, drop, your pee goes pop. The excretory system makes it hard to stop. Getting rid of waste, your body sees as poison. If you don't need it, your kidneys get rid of it. Bladder, urethra, and even your skin, passing on nutrients and taking out the toxins.
So many systems.
Endocrine, excretory,
Our body system.
nervous, reproductive, and digestive. Do you get me?
So many systems.
Respiratory, circulatory,
What are these systems for?
muscular, skeletal, immune. What it do?
Breathe in, breathe out, respirate to the rhythm. Blowing up your lungs with air, bumping like a bass snare. Blood and lungs with oxygen when you take a deep breath in. Swapping in the alveoli, CO2 goes bye-bye. What's my body gonna do with too much CO2? Get it out of me, my face is turning blue. I need to keep on breathing to keep my cells alive. Gotta get that oxygen so my cells can thrive.
Ba-bum, can you feel your heart pump? Circulatory system moves blood so you can jump. Made up of vessels, blood, and heart. It's a transportation line to your cells and body parts. PAC, veins, arteries, and capillaries. Blood highway from your heart throughout your body. Red blood cells carrying oxygen and nutrients. Gotta keep on circulating just to help you function.
So many systems.
Endocrine, excretory,
Our body system.
nervous, reproductive, and digestive. Do you get me?
So many systems.
Respiratory, circulatory,
What are these systems for?
muscular, skeletal, immune. What it do?
Immune system protects your body, keeping out germs and infections. You got
Main nervous system controls what you do. When to eat, what you feel, your brain tells you.
endocrine system has a whole bunch of glands to regulate hormones and send them out in strands.
Reproductive system in women and men allows us to make life and keep the world revolving.
So many systems.
Endocrine, excretory,
Our body system.
nervous, reproductive, and digestive. Do you get me?
So many systems.
Respiratory, circulatory,
What are these systems for?
muscular, skeletal, immune. What it do?
Muscles made of tissues, tissues made of cells. We all know now cells are made of organelles. Muscles in our body contract and relax. Bicep, quadricep, abdominals, calves. Tied together with tendons on the bone. Our muscles keep on pumping even when we're fully grown.
Well, you know, without your skeletal system, you would look like a glob of putty. Everywhere you turn, they be
reproductive and digestive, do you get me?
So many systems.
Respiratory, circulatory,
What are these systems for?
muscular, skeletal.
Well, that was amazing. Thanks for sticking with it. So, our challenge that we are working towards in this entire unit will be to, as a team, design and engineer Lego robots to demonstrate how 6 human body systems work together to perform a series of tasks. This is what we've been talking about all along, except now you're putting it into practice. You as a class are going to investigate 6 body systems really in depth and design your robots to perform the task for one of them. So for this, please write this down. Our engineering design vocab, we've got criteria. This is our desired specifications, which means requirements, elements, or features of the product or system that you need to solve the problem. For criteria, I'd really just write down desired specifications, and then anything else that you need to remember that. Our example problem is that we need a chair for our pet rock. Our criteria for this is that it must have a back seat and legs, and it needs to hold Mr. Rock 1 inch off the table. A constraint is our limits to the solution. Examples of constraints are oftentimes appearance, materials, budget, your space, or the time you have. Constraints for designing our chair might be you only have 3 note cards to work with, and you have to design a chair in only 3 to 4 minutes to work. A trade-off is an exchange. So a trade-off, you're saying, well, I'll get this, but getting this means I can't have that. Example of a trade-off could be that you want to eat an apple, but if you eat an apple, you're not going to have room in your stomach for your donut. So which do you do? Donut's much tastier, but the apple's much healthier. Which do you choose? Priorities. Finally, we've got priorities here. So priorities are the way you rank your criteria. And it's really saying, I think this is the most important thing, this is the next most important thing, this is the final most important thing. We don't really have any priorities for our example of Mr. Rock's chair, except that your chair needs to work. In the real world, money is usually a priority. We often want to have solutions that are cheap but effective. For our next activity, you are going to need to know these close reading symbols. So we have a copy of this for reference in Schoology under our daily handouts, but here they are as well. Our square or our rectangle is put around our vocab words. If you see something that makes you have a question in your head or you're slightly confused on, you put a question mark next to it. And I would make sure you add on, what is your question? What is your confusion? A star means that you think something is important, and you should write why you think it's important. Underline for the main idea, you circle for a supporting idea, and then you put an exclamation point next to something you think is really cool or really interesting, and you should also include, why did you put that exclamation point there? If you agree with something the author says, you'll put a plus sign. If you disagree with something the author says, you'll put a minus sign. And especially for disagree, make sure you say, here's why I disagree. Our next activity is going to be our close reading. We are going to need you to read the Rise Up article by Stephen Fraser, and you can get to that just by exiting out of this video and clicking the next button in Schoology. Your goal is to use your close reading symbols to annotate, to take notes on and decode the important parts of the Rise Up article. As always, scientists, stay curious and have a great day.